Hey, good morning, everybody, and welcome to day 18. We're on the last half of the semester. We got 7 more weeks, or 6.5 more weeks. Today, we're going to try to finish up chapter 3. We're going to do section 4, which is solving rationals and radical equations, and then section 5 deals with solving equations and inequalities that have absolute values. So if we get that far, we'll get that far, but definitely we'll do section 4 today. Yeah, every time I try to do something else, I get stuck. Okay, first off, rationals. They're fractions. Fractions with equal signs. So remember, ever since the beginning of the semester, I've always said, whenever you have fractions and equal signs, always get rid of the fractions. Whenever you have fractions and equal signs, get rid of the fractions. And those are the 5 steps I've always used. The first step, actually, in this case, simplify, which I mean, factor the denominators. Get them as simple as possible. Find the least common denominator of all the denominators. Multiply the LCD, the least common denominator, to each term. Reduce, or cancel. Multiply to remove the parentheses. Solve for x. And check your answers. And from here on out, it's going to be very important to check our answers, because we're going to find out that some of the denominators may work, some of them may not. So that we definitely always have to check it from now on out. All right, let's look at some examples. All right, so let's look at some examples. X squared over x minus 3 equals 9x minus 3. It's very important to know that you cannot cancel. If you have an equation, in other words, if you have a plus or minus on top and bottom, you cannot cancel. So in other words, if I had, say, x plus 6 over 2, I cannot cancel those out. If you're going to cancel anything, it has to be factored out first. You cannot cancel whenever there's plus or minus. You can't do that. So whenever you have a plus or minus, either top and bottom, put parentheses on it because they have to stay together. So this step one, find the LCD. That's the only denominator. So it's x minus 3. Multiply the LCD. Well, first off, we can't simplify it any further. So x minus 3 is as far as it goes, so we're stuck there. We found the LCD. Now we multiply. We have two terms here. This term and that term. So I multiply x minus 3 to this one. And then x minus 3 to the other side. So I'm multiplying the LCD to each of the terms. Next step is reduce. So that cancels with that. That cancels with that. So what we're left with is x squared equals 9. Multiply to get rid of parentheses. And since we don't have any, we don't have to worry about that. Solve for x. Since it's quadratic, we have to move everything to one side. How do we know it's quadratic? Because it's got a square. So we have x squared equals 9, so we subtract 9 from both sides. We have x squared minus 9 equals 0. Solve for x. Actually, we could have just solved it this way. We could have just used, which we have two ways of doing it. At this stage here, we could have square rooted both sides. When I take a square root of a squared number, I got to put a plus or minus in front of it. Square root of 9 is 3. So those are my answers, plus or minus 3. Or I could factor it out. This is the difference of two squares. It's x squared. 9 is made up of 3 times 3. So it's x squared minus 3 squared. And the rule of that is if you have two terms that are the same and they're both squared and a minus, just put A and B into both those and then different signs. So that's the difference of two squares. So we have x and 3, x and 3, one's plus, one's minus. Set them equal to 0 and solve. Which is what that says. We're not done yet because step 6 check your answer. The original question was this. We have two possible answers. So when x equals -3 or when x equals 3. We have two of those we have to check. So I put -3 in every place I see an x. So I have -3 squared over -3 minus 3 equals 9 over -3 minus 3. -3 squared is 9. -3 minus 3, they're both negative. 3 plus 3 is 6. They're both the same. So it works. So -3 is a solution. Let's try +3. So anywhere I see an x in this equation, I put a 3. 3 squared is 9. 3 minus 3 is 0. Now, even though they're the same, you cannot divide by 0. So that one doesn't work. So the only answer we have for our equation is x equals -3. That's our solution. And let's look at the next example. 2 over 3x plus 6 plus 1 over x squared minus 4 equals 4 over x minus 2. Let's review the steps. Factor the denominator. So what can we do with this one? They both have a 3 in common. So on the bottom, if we take out a 3, we divide by 3. So we have x 6/3, x plus 2. So this first parenthesis, I could rewrite it as 3 times x plus 2. The second denominator is x squared minus 4 is made up of 2 squared. So it's a difference of 2 squares, x and 2. So it's x2, x2, one's plus, one's minus. And the last one is as far as it can go. So those are my denominators. From there, we can see what we need. We have to find the LCD. That's step 2. So what do we have on the bottom? We have a 3. So we need a 3. We have an x plus 2. This one needs one. And then we also have an x minus 2. And there's an x minus 2. So this is my LCD. multiply the LCD. So we have one term, two terms, three terms. So we put the LCD out in front. We have 3 times x plus 2, x minus 2. Three x plus 2, x minus 2. Equals 3 x plus 2, x minus 2. I put the LCD in front of each term. Step 4 says reduce or cancel. So in this first term, the 3's cancel, the x plus 2. So what we have left is 2 times x minus 2. There's a plus. The x plus 2 cancels, the x minus 2. So we just have 3 times 1 equals the x minus 2 cancels. So we have 4 times 3 times x plus 2. Five is multiply to get rid of the parentheses. So 2 times x is 2x. Positive times negative is negative. 2 times 2 is 4. Positive times positive is positive. 3 times 1 is 3. Order of operations said do inside the parentheses first. We can't do anything in here, so we get rid of parentheses. So we have 3x plus 6. I have to do it again. 4 times 3 is 12. Positive and positive is positive. 4 times 6 is 24. Just here if you want to. Combine like terms. Whenever you get rid of parentheses, combine like terms. So we can combine these two. Negative and positive. 4 is bigger, so the answer is negative. 4 minus 3 is 1. Now we solve for x. That's step 6, solve for x. Remember, whenever we have x's on both sides, which one do you move? The smaller one. Always move the smaller to the larger. It's a positive 2x, so we subtract 2x from both sides. We have negative 1. 12 minus 2 equals 10x plus 24. Subtract 24 from both sides. They're both negative. 24 plus 1 is 25. Try to get x by itself, so we divide by 10. Negative 25 over 10. We see that we can go further. They both have a 5 in common. 5 goes into 25 5 times. 5 goes into 10 twice. So that's my solution. Remember, step 7 is check your answer. Well, we can save ourselves the time by looking at, once we find the LCD, whatever x makes any of these equal 0, we cannot use. To check your answers, we can look at the LCD. Our LCD was 3 times x plus 2 times x minus 2. Any x value that makes any of the LCD parts equal 0, we cannot use. So we set x plus 2 equals 0, x minus 2 equals 0. These are the two x's that we cannot use. Two or negative 2. As long as your answer isn't either of them, your answers are good. They work. So instead of checking your answer, you can just look at your denominators, see what you have. It makes it much easier that way. For example, let's look at our first one. When we had x minus 3 equals 9x minus 3. Our LCD here is x minus 3. So set that equal to 0. So x cannot equal 3. Any other value other than 3 will work for us. So when we work this out, we multiply both sides by the LCD, those canceled. And we square rooted both sides. We got x equals plus or minus 3. X equals positive 3. X equals negative 3. That's from what we did this one. But our LCD says we cannot use 3. So we cannot use that one. That's our only solution. So we could preempt our solution check by looking at the LCD from step 1 and step 2. So far, so good? All right, let's move on to radicals. The hardest part of that is factoring the denominator, and then once you see that, then finding LCD. That's the hardest part. All right, what are radicals? They're square root equations. So what rule do we have for radicals? What's our domain? What's the graph look like? If you remember the graph, it starts at 0 and it goes like this. So x has to be greater than or equal to 0. In other words, inside the radical cannot be negative. If it is negative, then take out the negative sign and place an I in front. Remember, whenever you have an I inside a square root, a negative, it becomes imaginary. So here's an example. Square root of 3x plus 1 equals 4. So let's look at the steps here. When solving radical equations, isolate the radical. In other words, you have to have a radical on one side and everything else over here to solve it. Remember, we're solving for x. What do you have to do to the, how do you get rid of the radical? How do you get rid of the square root to get to the x? What's the opposite of square root? Square. Square both sides. Remember, place a plus or minus in front of the other side. So when I square both sides, well, no. Remember, place a plus minus when you square root something squared. So we square both sides here. So that disappears. So we have 3x plus 1. 4 squared is 4 times 4 is 16. Solve for x. Three x equals 16 minus 1 is 15. 15 divided by 3 is 5. Again, check your answer. So CYA. Always check your answer with the original equation. Why? Why would you always want to check your answer with the original equation? That's the only one that's true. If you messed up anywhere along the way and you check a wrong answer with a wrong step, you'll get a wrong answer. So the only way you can check if it's real is go back to the beginning, because that's the only thing that you haven't touched. So plug it in there. 3 times 5 plus 1 equals 4. 15 plus 1. 15 plus 1 is 16. Square root of 16 is 4. So that's a good answer. Okay, here's another example. What's the first step? Look at the notes you just had there earlier. What's the first step of the process? Is the radical by itself? Nope. What's it got? A 3 in front. How do we get rid of the 3? How is it connected to the radical? Is it added, subtracted, multiplied, divided? It's multiplied, yeah. Because there's no plus, there's no minus, there's no division sign there. So it's multiplied. What's the opposite of multiplication? Division. So we divide both sides by 3. Nine divided by 3 is 3. Now we have it's isolated. So now we square both sides. And solve for x. X equals 7. Check your answer. 7 plus 2 equals 9. That works. So x equals 7 is a good answer. How about this example? Yeah, we have it's same as if it was just solving for x's. Always get rid of pluses minuses first, then get rid of multiplication division, and then solve for x. So here we have to add 2 to both sides. Then divide by 3. 6 divided by 3 is 2. Now here's where we square both sides. The square and square root cancel. And subtract 2. So we're saying that x equals 2. Let's see if that's a good answer. Two plus 2 minus 2 equals 4. 2 plus 2 is 4. Square root of 4 is 2. 3 times 2 is 6. 6 minus 2 is 4. So it works. So x minus 2 is a good solution. It's pretty straightforward, but it gets more difficult. What if we had 2 radicals? 2x minus 5 minus x minus 3 equals 1. What if we had 2 radicals? If you have 2 radicals, we have to do the process twice. First step, isolate a radical. Either one, doesn't matter which one you want to isolate. So let's leave this one alone. So we do that to both sides. Subtract x, or add x, radical x minus 3 to both sides. So 2x minus 5 is equal to 1 plus radical x minus 3. We isolated a radical. What's the next step after that? Look at your steps. I mean, this is all procedural. What does it say? What's step 2 say in the procedure? Square both sides. So we square both sides. This, remember, is an equation. It's got to stay together on the right-hand side. So on the left side, those cancel. So I have 2x minus 5. On the right-hand side, what I have is 1 plus radical x minus 3 times 1 plus radical x minus 3, or x minus 3 plus 3. That's what that square means. It's whatever's underneath it is multiplied to itself. So I have 2x minus 5. Now I got to distribute these. 1 times 1 is 1. Positive times positive is positive. 1 times radical x minus 3 is x minus radical x minus 3. Positive times positive is positive. Radical x minus 3 times 1 is radical x minus 3. Positive times positive is positive. Radical x minus 3 times radical x minus 3 is radical x minus 3 squared. Whenever you get rid of parentheses, always combine like terms. Those are like terms. This is not the same because it's squared. These aren't squared. So I got 2x minus 5 equals 1. This plus this is 2 of those. On the right-hand side, we have the square root and the square. They cancel. One plus 2 radical x minus 3 plus x minus 3. Combine like terms. On the right-hand side, I have 1 minus 3. So I have 2x minus 5. 1 minus 3. Since 3 is bigger, it's negative. 3 minus 1 is 2. Plus x plus 2 radical x minus 3. Of course, you see now what we have to do. We have to isolate the radical again. We have to repeat the whole process. So we have to get everything else on the other side. So we add 2. We subtract an x. Two minus 1 is 1x. Negative 5 plus 2, 5 is bigger, so it's negative. 5 minus 2 is 3. We're going to stick with the rules so far, and I'll show you that we can just go ahead and do, when you square both sides, you can leave a coefficient there, but it makes things, you have to make sure you take that one separately. So I divide both sides by 2. Actually, we'll look at this one in a second. So I divide both sides by 2. So I have x minus 3 over 2 radical x minus 3. It's by itself, so I square both sides. Which means this one means I have an x minus 3 squared over 2 squared. And on the right-hand side, those cancel. X minus 3 times x minus 3 over 4 equals x minus 3. We have a fraction and an equal sign. So multiply both sides by 4. Those cancel, so we just have x minus 3 times x minus 3 equals 4x minus 12. We have to get rid of the parentheses. X times x is x squared. Positive times negative is negative. X times 3 is 3x. Positive times negative is negative. 3 times x is 3x. Negative times negative is a positive. 3 times 3 is 9. Equals 4x minus 12. Combine like terms. -3 -3 is -6. So now what do I do? What's that? Well, since it's quadratic, I have to consider it equal to 0. So everything has to go over to one side. I subtract 4x from both sides, and I add 12. It has to be equal to 0. They're both negative. 6 plus 4 is 10. They're both positive. 12 plus 9 is 21. And what you do now is can we factor these, or do we have to use one of the other methods? How can you know we can factor? To determine if it's factorable, if the first number is a 1, do we know two numbers to multiply to equal 21? When you add them, you get 10. It helps if your multiplication skill is pretty good. What equals 21? 7 times 3. 7 plus 3 is 10. So yes, in this case, we can factor. So we got x's. The second sign's a plus, so they're the same. They're both going to be minus. And it's 7 times 3. Set both of those equal to 0. And we get our two numbers. And we'll check those in a second. But let's go over here now, back to this one. And we're going to square both sides. The left side is going to be x minus 3 times x minus 3. And the right side, since it's a product, you have to distribute it to both of those. We're going to have 2 squared and square root of x minus 3 squared. We have x squared minus 3x minus 3x plus 9, 4 times those two cancel, so it's x minus 3. X squared minus 6x plus 9 equals 4x minus 12. Which is what we had here. Which is what we had here. All right, let's check our answers. The original equation was x minus 3 equals 2 radical x minus 3. No, that was after we said and done it. It was 2x minus 5 minus x minus 3 equals 1. There. So we have to try both of those numbers. So when x equals 7, and then when x equals 3. 2 times 7 minus 5. 7 minus 3 is equal to 1. 2 times 3 minus 5 minus 3 minus 3 equals 1. So we do both of those. Two times 7 is 14 minus 5. 7 minus 3 is 4. 14 minus 5 is 9. Square root of 9 is 3. Square root of 4 is 2. So 7 works. Again, this part here, that's the stuff we did in chapter 1. You guys should be able to do this. So it shouldn't be much of a problem. 2 times 3 is 6 minus 5. 3 minus 3 is 0. 6 minus 5 is 1. Square root of 1 is 1. Oops. So they both work. Let's do another one. X minus 3 plus x minus 5 equals 4. Let's make it x plus 5. First step, isolate a radical. So let's subtract x plus 5 from both sides. We isolated the radical, so we square both sides. Since that's an equation, I got to put in parentheses. Square root and the square cancel, so I have x minus 3. 4 minus radical x plus 5 times 4 minus radical x plus 5. Left side's okay, so we got to FOIL out, multiply to the second side, the other side. 4 times 4 is 16. Positive times negative is negative. 4 times radical x plus 5. Negative times positive is negative. 4 times radical x plus 5. Negative times negative. Radical x plus 5 times radical x plus 5 is radical x plus 5 squared. If you want to close the door, you can. It's up to you, because you're right there. Combine like terms. -4 is -8. Radical x plus 5. It's amazing how quiet it makes it. Minus the square root and the square cancel, so I have an x plus 5. Very important. Because the sign was a negative right here. And if I would have just canceled that, leaving x plus 5, is that negative to both of those or just to the x? It's supposed to be both of them, because it was inside the radical. This negative makes the whole thing negative. So if I don't put a parenthesis around there, then I change the equation. So whenever you have a minus in front of anything, put a parenthesis around it. Everything after a minus, put a parenthesis around it. So now we can distribute that negative. So it becomes a negative x and a negative positive, -5. Combine like terms, we have a 16 and a -5. So 16 minus 5 is 11. Minus x minus 8 radical x plus 5. So now we have to isolate that second radical. Subtract 11 from both sides. Add an x to both sides. Two x, they're both negative, minus 3 plus 11 is 14. Now, in this case, it's more simple. Well, there's a couple of things we can do. But to keep only using one rule, let's go do that, is let's go ahead and square both sides. Since we've seen what to do already with that. So we have a 2x minus 14 times 2x minus 14. And this negative 2 goes to both of those. So it's negative 8 squared radical x plus 5 squared. Two times 2 is 4. X times x is x squared. Positive times negative is negative. 2 times 14 is 28x. Negative times positive is negative. 14 times 2 is 28x. Negative times negative is positive. 14 times 14 is what? 226, 16, 196. Negative 8 times negative 8 is positive 64. And the square and the square root cancel, so we have x plus 5. Combine like terms. So we have 4x squared. They're both negative. So 28 and 28 is 56. We have 64 times x. 64 times 5. 320. Since it's a quadratic, everything has to go over to one side. So I subtract 64x from both sides. And I subtract 320 from both sides. They're both negative. 6 and 4 is 10. 120x. 320 is bigger than 196, so it's negative. 320 minus 196, borrow the 1. So it's 124. Equals 0. Okay, before we go any further, we notice that each one of these numbers is divisible by 4. Is 12 divisible by 4? Yes. 12 is. Is 4 divisible by 4? Yes. So we can divide every term by 4 to make the numbers smaller. Four goes into 12 3 times with a 0 behind it. 4 goes into 12 3 times. 4 goes into 4 once. We have x and x. The second sign's a minus, so they're opposite signs. And the bigger number is negative. So what times what is 31? When you subtract them, you get 30. what times what is 31? Let's look at those possibilities. 1 times 31. That's a fact. It's a prime number. Can't go any further. How about 31 minus 1? So the answers are 31 and 1. The bigger number, so 31 goes here and 1 goes there. Set them both equal to 0. And those are your answers. The original equation was x minus 30 plus x plus 5. Now we have to check both of those. So inside there, x is -1, -1 minus 3, -1 plus 5. And the other side, and we're seeing x put a 31. How about on the left side? -1 minus 3 is -4. -1 plus 5 is 4. -31 minus 3 is 29. 36. So what's your conclusion? Neither of them work. Because here we have a negative inside the square root. Here we have an imaginary number. That does not equal 4. Square root of 36 is 6. That's already bigger than 4. Square root of 29 is 3 square root of 3. That doesn't equal 4. So no real solution. It happens. It can happen. It won't always be perfect numbers. Actually, no, 29, that's 27. No, square root of 29 is a prime number. Again, it's plus 6. It's much bigger than 4. We're done. So neither of them work. So that's it for that section. The last section, we're not going to cover today, deals with inequalities and equations with absolute values. You don't get one answer. Whereas if we had If we had this, what would the answer look like? The graph of the square root of x looks like this. How about that? Now I'm saying this is this graph right here. It's just each of these dots here. But think of inequality. These are all the y values that are less than absolute value of x. In other words, it's all of these. That's what we're going to cover next. It's not just one answer. It's an infinite amount of answers. You just have to see one side of it, either above or below the graph. That's what we'll do next week. Right? All right. Have yourself a great, safe weekend. Enjoy the sun.